Today we're going to continue working with lost signs, okay? But we are going to be talking about that special case where we could possibly get two sets of answers for everything called the ambiguous case. So we're going to find angle B in this setup. So angle B is right here, so let's put an X in here. That's the one we want to know. Now we're going to be able to use the lost signs because we have an angle and a side opposite. That's why we're going to be able to use it. Now, we want to find this angle. But I'm missing this one. I'm missing this side. So I can't solve for that. But what I can do, I'll get another color for our highlighter here. Is I can solve for this angle using the law of signs. And if I can solve for this angle, I can then easily find this third angle in the triangle using triangle sum. So we're actually going to be solving for this angle right here. We're going to call it y. Okay? And then so we're going to indirectly solve for the angle x by finding this angle, this other angle in the triangle y, which then in turn we can use to find this. But we're going to have to be careful because now we've drawn all over this triangle. We're given two sides and an angle not included. So this is a side-side angle triangle, which means it has the chance to be ambiguous because we're solving for an angle in that triangle. So it doesn't change how we go and actually find the angle to start with. It just means that we can have a second answer. So let's go ahead and set this up. We're going to solve for y here. So we're going to get 9. Make that a little prettier. 9 over the sine of angle y, and that is going to equal 12 over the sine of 43. We're going to cross multiply and solve, so we get 12 sine of y equals 9 sine of 43. So we'll just go ahead and continue to solve this. Divide the 12 to the other side. So we get 9 sine of 43 divided by 12. And finally, that angle y is going to be the inverse sine of 9 sine 43 divided by 12. So let's plug that in and see what angle we get. And a whole number will be fine for this one. So 9 sine of 43 divided by 12. Make sure you're in degrees. Don't forget to be in degrees. Inverse sine of that answer. And I get 30.7. We're going to say it's 31 degrees today. So that means this angle down here can be 31 degrees. Now, the or, now remember with our or, what we're saying is, well, this value of y that we found has an angle of rotation of 31. But because sine is also positive over here in the second quadrant, it can have a reference angle of 31, which means the actual angle of rotation is 180 minus that 31. So it's 149 degrees. So our or right here is 149. Now, we need to check it. The 31 is going to fit because 43 plus 31 is less than 180, leaves us room for this angle. That'll work. But now we need to check the other way. 43 plus 149, is that less than 180? That's 192. So when we look at this and we check this one, we say, well, 149 plus 43, that equals 192 degrees. Is it possible to have a triangle where two angles are bigger than 180? No. This number has to be less than 180 degrees. Since this is a false statement, even though it was possible, does it actually happen this time? Doesn't. So that means, is there an or for this one? There's not. It doesn't work. It doesn't always have to work. So now we can actually use this to find the angle x. Because what do we know about 43, y, and x? We know they all add to 180. So 180 minus 43 plus 31, because those are the other two, will tell us x. So 180 minus 74 is what, 106? So that means that my x angle up here is 106 degrees. So something to think about. It doesn't always have to work where you'll find that other angle when it's ambiguous. It just could, okay?